Today we are going to study about colloids. Colloid is a mixture where the size of the particles of the dispersed phase they range between 1 to 1000 nanometer. So size of particles of colloid, or you can say the particles of dispersed phase, they lie in the range of 1 to 1000 nanometer. And you have studied the general properties of colloid in 9th standard, that it is a heterogeneous mixture and quite stable because the particles of colloid keep on moving. They are in continuous zigzag motion, they are randomly moving. So before we study the properties of colloid in detail, we'll try to understand the classification of colloids. So colloid, which is a mixture wherein the particles of dispersed phase are between 1 to 1000 nanometer, they are further classified into three categories. The first category of classification is based on the physical state of dispersed phase and dispersion medium. So based on the physical state, that is solid, liquid or gas, of dispersed phase, that is the particles of the colloid, and dispersion medium, that is medium of the colloid, there are various types of colloids. So when the particles of the colloid they are in solid state and dispersion medium also is in the solid state, then such a colloid is said to be a solid sol. Dispersed phase as well as dispersion medium both are in the solid state. So in this gemstones they are the example of solid sol. Second type of colloid is the colloid in which the dispersed phase is solid and dispersion medium is liquid, and such colloids are termed as sol. So dispersed phase solid and dispersion medium liquid. So all the cell fluids they are the examples of sols. Third type are the colloids in which the dispersed phase is solid and dispersion medium is a gas. Dispersed phase is solid and dispersion medium is a gas, and they are termed as aerosol. So smoke, dust, they come under aerosol. Next type are called as gel. Gel means when the dispersed phase is liquid and dispersion medium is solid. Such colloids are termed as gel. So from the term itself you can remember the example that jellies they are example of gel where dispersed phase is solid. Now next type of colloid based on physical state of dispersed phase and dispersion medium are emulsions. Emulsions are liquid-liquid colloids where the dispersed phase as well as dispersion medium both are liquids. So milk, blood, they are example of emulsions. Now next comes the aerosol. Aerosol, this term you have already heard here. Aerosol, wherein the dispersed phase is solid and dispersion medium is a gas. When dispersed phase is liquid and dispersion medium is gas, then such colloids are also called as aerosols. I repeat, when the dispersed phase is liquid and dispersion medium is a gas, such colloids are also called as aerosols. तो clouds इसमें आ जाते हैं, mist है, fog है, they are also liquid gas colloids which are called as aerosols. Next kind is solid sol, where the dispersed phase is a gas and dispersion medium is a solid. They are called as solid sol. So this term also you have heard here. Solid sol, solid colloids को भी solid sol बोलते हैं और gas solid कोलॉइड्स को भी सॉलिड सोल बोलते हैं, क्योंकि दोनों में ही कॉमन क्या है, सॉल्वेंट, दैट इज डिस्पर्शन मीडियम इज इन द सॉलिड स्टेट. So solid soul, under this the example is rubber, foam. These are the examples of solid soul. Lastly, when the dispersed phase is gas and dispersion medium is a liquid, such a colloid is called as foam. Dispersed phase is a gas, dispersion medium is a liquid, such a colloid is called as foam. तो इसमें सोप लैदर आ सकता है, झाग, साबुन का पानी का झाग, जैसे बबूले आते हैं उसमें, सो दैट इज एन एग्जाम्पल ऑफ फोम. फिर विप्ड क्रीम, that is also an example of foam. So these types of colloids, they are classified on the basis of physical state of dispersed phase and dispersion medium. Now next category of classification is based on interaction between dispersed phase and dispersion medium. So based on interaction between dispersed phase and dispersion medium, colloids are classified into two types: lyophilic colloid and lyophobic colloid. Lyophilic colloids are those colloids in which the dispersed phase has affinity for the dispersion medium. When we say dispersed phase has affinity for the dispersion medium, it means such colloids, they are more stable because the particles of dispersed phase will be held to the particles of dispersion medium. The term lyophilic, as it indicates that having affinity or towards the dispersion medium or liquid loving. So in this type of sols or in this type of colloids, mainly starch sol, gum, rubber or gelatin are examples of lyophilic colloids. Second category is lyophobic colloids. Now the term lyophobic means liquid hating. So the colloids in which the particles of dispersed phase do not have affinity for the dispersion medium, such colloids are called as lyophobic sols. So lyophilic, when there is interaction, positive interaction between the dispersed phase and dispersion medium, then that is lyophilic colloid. And as I gave you example that starch, gum or gelatin, they are examples of lyophilic colloids, and these are stable, and these colloids are reversible, means again the components can be separated by simple methods. Lyophobic colloids, where the particles of dispersed phase do not have affinity for dispersion medium, hence they need a stabilizing agent to be stable, or else they will not be stable. So for making them stable, we add small amount of stabilizing agent, and that keeps the particles of dispersed phase in contact with or binded with the particles of dispersion medium. And so when we talk about the stability of lyophobic colloids, they are stable only on adding stabilizing agents, and they are irreversible. They are irreversible. So you cannot bring back the dispersed phase and dispersion medium from a lyophobic colloid. So this was the second category of classification based on the interaction between the particles of dispersed phase and dispersion medium. Now the third classification of colloids is based on the type of particles of dispersed phase and dispersion in the dispersion medium. So based on the type of particles in a colloid, Colloids are of three types: multimolecular colloid, macromolecular colloid, and associated colloid. Now, the first type, that is multimolecular colloid. Multi, as the term indicates, means many. So, in multimolecular colloid, large number of small atoms or molecules, they aggregate together and they come in the colloidal range, that is between 1 to 1000 nanometer. So initially they are not in the colloidal range, their size is less than 1 nanometer. But when they form a colloid, the particles of the dispersed phase, they get aggregated and come in the range of 1 to 1000 nanometer. So in this we can have example of sulfur sol S8, that is sulfur sol is an example of multimolecular colloid. Second type of colloid based on the type of particles of dispersed phase, that is macromolecular colloid. The term macro means large or big. So macromolecular colloid are the colloid in which the size of the particles of dispersed phase, they are very big and they are already in the colloidal range. So such type of colloids, they are called as macromolecular colloids. So the colloids of protein, then colloid of cellulose, they come under the example of multimolecular colloid. All polymers also will come under macromolecular colloid. Now the third type, that is associated colloid. Associated colloid, they are also called as micelle. They are also called as micelle, and this term you are familiar with when you have studied the cleansing action of soap. So associated colloids or micelle, somewhere it is associated with soap. So now there are some substances which at low concentration behave as normal strong electrolytes, but at higher concentration they exhibit colloidal behavior. Why? Due to association or aggregation of particles of the colloid. So initially when the solution is dilute, they behave as normal strong electrolytes, means they will be conducting, and it it will behave as a true solution rather than a colloid. But at higher concentration it becomes a colloid due to aggregation of particles of the dispersed phase. So if we take the example of soap solution, soap solution is a colloid, or it behaves as associated colloid at a certain concentration which ranges between 10 to the power minus 4 molar to 10 to the power minus 3 molar. So at this concentration of soap solution, it behaves as an associated colloid, and this concentration of soap solution, or the concentration of the solution when it behaves like an associated colloid, is known as critical micelle concentration. It is abbreviated as CMC. It is called as critical micelle concentration. So the aggregation of particles take place only at a definite concentration range, or you can say the micelle formation takes place at a definite concentration range, and the formation of micelle takes place only above a certain temperature, only above a particular temperature, that is known as Kraft's temperature. That is known as Kraft's temperature. I repeat that the Kraft's temperature is the temperature above which a true solution behaves as an associated colloid. So at that temperature, the concentration of the colloid also will be between 10 to the power minus 4 to 10 to the power minus 3 molar or mole per liter, and hence it will form a micelle or it will be an associated colloid. So this concentration of a colloid where the aggregation of particles of dispersed phase takes place and it behaves as associated colloid is known as critical micelle concentration. Again, if you dilute the solution, it will behave as a true solution and it will be highly conducting. So when we talk about the term micelle, so micelle ये आपने cleansing action of soap में पढ़ा, and you know that the soap molecule in the aqueous state arranges itself in a definite manner and forms a micelle. So in the next topic we will be studying the cleansing action of soap or how the micelle formation takes place.